am I able to find a linear equation now? What did we learn just now? Let's turn back. What were we given just previous to that? What were we given? Turn back to the last 4 problems we did. We were given a slope, yeah, which we got out of 2 points. Here, on this one, are we given at least 2 points? Yeah, we're given a bunch of points. So guess what? We're going to be able to do the same thing. So, this one, well, we're going to be doing the exact same thing we just finished doing on the last 4 problems. So, we're going to say, all right, I already have my slope, so I'm going to pick a point. Which point do you guys want to pick?
1070.
No, the first one.
Just pick always the easier one. Typically, the first one is the easier one, and this one, 4 and 34, why not? We'll pick that one. So I'm going to label over here, 4 and 34. I'm going to pick that point. 4, 34. Let's go ahead and label it, x1, y1. Let's label it, x1, y1. x1, y1. So now, what's going to be my very first step? Let's look back at the next page. What was my very first step? Find the slope. Do we already have the slope?
Yeah.
So what's my second step? Plug it in. Into which equation? The point slope form. So let's write the point slope form and let's plug it in. So we're like, okay. So we got y minus y1 equals m parentheses x minus x1. And I'm going to plug in what I have. My m, we know it's 6, so it's like my x1 is 4, my y1 is 34. So I got y minus 34 is equal to m, the 6, parentheses x minus 4. X minus 4. But we don't like it when it's in that mode. So what did we do? We distribute and then we solve for y, right? So let's distribute and solve for y. Let's distribute and solve for y. So we got y minus 34 is equal to 6x minus 24. And then y minus 34 is equal to 6x minus 24. What's going to be my final step? So let's do that. Let's add 34 to both sides. Add 34 to both sides. And we got y is equal to 6x plus 10. And that, ladies and gentlemen, is how we do that.
This is so easy.
I am glad you think so.
And boring.
So, this is what we're going to do. The next one is going to be very similar. Remember, before we start doing anything, read the word problem. Don't be like Mr. Contreras and just get into the action and you're assuming that it's asking for the same thing. Read the word problem, be like, oh, what is it asking me for? Oh, very similar as this one. So we're going to want to do that, that, and that. So let's go ahead and we can work with a partner. We can work with our partners. Let's go ahead and take the next, let's say, 6 minutes to do this. 6 minutes? I think that's going to be enough. Let's work. 6 minutes. What's up, John? So in this one, you just need to tell me a point. I don't know. Good. How much am I changing? 42. 36, how much am I changing? 6 Okay.
I'm trying to
How about
constant rate of change first.
6 to 9. So 9 minus 6, what is that? And then do the same on the 4 minus this one. Okay? Then we're going to do the same on the 302 minus this one. This one minus this one. And this one minus that one. Okay?
I can't hear you.
Good job, Thomas. Make sure you tell me why it's a linear function. If you think it's a linear function, you gotta tell me why, okay? Don't just tell me it's a linear function. You know you won't get full credit. You gotta tell me why as well. Yeah, if you want to abbreviate as croc, that's okay. It has a constant rate of change. As a croc. Come on. Okay. Are you doing Christopher? So you already, but we have to be careful about that. Even though this did end up being a linear function, make sure we find out that yes, it can be a linear function before we start trying to create the equation. So imagine trying to create the equation of a linear function, but the thing is a circle. Right? That's why. So it's like, yes, it's a linear function, and then we create the equation. Good job. When you finish, move on to number 5 and 6. Notice how he's just asking for the point. X1, Y1. What do you need for a linear function? Does this one have one? That's right. No, this is not these mine. Yes, it's a linear function. That's a constant. How you doing, Thomas?
Which one was it that?
Yeah? Good. Awesome. Here, I'm seeing most of us are finishing. Good job, good job. Let's move on to 5 and 6. 6 is going to be tricky. It's going to challenge you. Try to figure it out. Let's see it.
Yeah.
If there's going to be linear, why? Okay? Thomas, it didn't go up yet, right?
No. Because if not, I would have ran over there already.
I know. All right. It seems like most of us are finishing. You still got about a little less than a minute.
Remy.
On number 5 and number 6, right? Since most of us are finishing that, it's just asking for the point. It's just saying identify the point. So you just need to tell me the point. X, comma, Y. On this one, you know how we got the point over here. So you just need to tell me the point. Oh, it has to be that point. Which point do you want to use? Pick one. Which one do you want to use? The first one? Okay, write it over here. 3, comma, 176. So now label it as so now multiply it into a one. Y minus Y1 equals X minus X1. Good job. Good job. What's up, baby? Tricky, right?
Oh, no,
Careful,
no,
that's your white one. That's your white one. On that side.
Oh, yeah.
All right. Yep. Here, let's go ahead and backtrack. I know most of us finished this. I know most of us are eager to move on. I just want to confirm that you got it right and that we didn't make any single little mistakes. So, here, I know most of us are finished. We're on the next page. I know. Let's come back to this one. Let's come back to this one. Word problems are going to be a big struggle for us, so we need to make sure that when we do them, we need to check them, and we need to make sure that we got them right. Yes, I like it. Now, the very first thing, Larry, you read this problem? What was like the thing that caught your attention? What were they asking you for?
Asking me if it was a linear function.
If it was a linear. All right. Going off of that, Kimberly, how do we know when something's a linear function? It has a constant rate of change. Going off of that, Stephanie, how do I find a constant rate of change for this? y2 minus y1 over x2 minus x1. Yep, good job. Whenever I do that, and I do it from this side, y2 minus y1 over x2 minus x1, y2, y1, x2 minus x1. John, what do we get over here on this side? 302 minus 176, what did you get?
Like the slope?
Yeah, well, yeah. Yes, we're going to the slope, but just 302 minus 176. What did you get? You have it in your paper? What did you get? 126. And then 6 minus 3? Awesome. How about for the next ones? Did you get relatively the same thing for the next ones? Yeah, from here to here, from here to here, from here to here, from here to here. Notice how it's the same. 3, 3. So Kimberly, does that have a constant rate of change? Okay, Kimberly says yes, I'm good with yes. 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 And we say yes, it's linear. Yep, remember, you cannot just say yes, it's linear. You gotta tell me why it's linear. Thomas, you're eager to say this. Why?
Oh, because it has a constant rate of change.
Because it has a constant rate of change. Because it has, Thomas, what is the abbreviation we're using for constant rate of change?
Crop.
Crop. Because it has a crop. Remember that funny word. It has a constant rate of change. Sometimes, whenever, if you choose to write constant rate of change on your exit ticket, for example, I will understand what you're talking about. Just remember what it means. Constant rate of change, meaning that's a slope. Same thing. Once it has a crop, you're like, okay, this is linear, so I can definitely form my equation. So I'm going to choose the first point for us. I'm going to say we're going to use that one, 1 and 76. Alexis, which formula did you initially decide to use? Which one or that one? Bottom one, right? We don't get the y-intercept over here, so we can't use that one. So we're like, okay, cool. So then 3, 176. Tell me the equation, how that would have won. Did you use that point?
Yeah.
All right, tell me the equation.
Y minus 176
Equals?
42
Yep.
parentheses x minus 3.
Millie, what am I doing over here on the right side? What's funny about that? On the right side. When I do that, what do I get, Millie?
42x.
Yep. Minus a big number. What's 42 times negative 3? Negative what?
126.
Okay. Final step, Wilfredo, what is it? And finishes off with the equation.
Add 176.
And you get?
Y equals 42x plus 50.
Plus what? 50. Here, raise your hand if you got that one. 42x plus 50. Did you get it? Pretty sure you did, yeah. Did you get it? You did. Give yourself a pat on the back of that. I'm doing a good today. I'm going to do amazing today on the same ticket.
Exit ticket.
Right, ticket. What time is it? It's 10:28. What time do we leave? Remind me. 51.
38.
I wanted to give you 15 minutes. 51. So minus 10, 41, minus 5, 36. We got 8 minutes from that. We got 1, 2, 3, 4, 6 problems. So let's go ahead and take the next 8 minutes to work on the next 6 problems. And right after that, we're going to take the exit ticket, okay? I'm gonna go check in with some of us that are seeing how we're doing. Remember, if you're confused at any given point, use that little checklist that you're using. I'm going to allow you to use it on your exit ticket. Okay? What? No, just points low form. If it's just asking you for the points low form, remember, we just do the points low form. If it's asking us for the slope intercept, that's when we gotta solve. So you got about 6-7 minutes.
Yeah.
So, but instead of y1, what am I going to instead of x1? That's right. Here, I do want to note something. Be careful if I ask you for the point slope form, just give me the point slope form, okay? You don't need to solve for y. But if I ask you for the slope intercept, the one that only has the slope and the intercept, then you need to solve for y, okay? Because I'm seeing some of you guys are doing it, but on the very first two, you're solving for y. And yes, you're correct, but you didn't need to. You're just doing extra work, okay? Just FYI. So it's going to be, it's x minus a number, right? X minus, x minus a number, right? What is the number that I'm subtracting?
The only thing that changes is
What is it?
addition.
Negative, negative? Good. So it just actually becomes x. Awesome. Does that make sense? That's what it's a plus. It's okay. What's up? Yeah? Oh my God, I forgot. Here, do me a favor. Can you go next door and get all 3 answer sheets that I from there this morning? They're going to be, one's going to be over here on this window. The other one's going to be on that window. The other one's going to be on that window. That's on along the outside of the window.
Why you put that next?
Thank you, Rick.
Possible.
Good job. Here, remember what I said about this one? What am I asking on this one? So this one didn't move. You did it right, but you see, that was it. You got it right already. No tenías que hacer algo. No. Good. Had I asked for a slope intercept, could practice it, you could laugh. Good job. Good. Yeah.
When it comes to that, it comes down to like,
Good. This one's too
Another one? So, but on this one, yeah. Slope intercept, right? We want to get this, right? But remember, we can start here and just solve for y. So do this, and then if we solve for y, we get it. Remember,